Now, coming to the, we can say second law of thermodynamics. But before moving to the second law, we should know what are the limitations of the first law of thermodynamics. What are the limitations of the first law of thermodynamics? First we should know, then only we should move to the second law, isn't it? Fine. So the first law simply it indicates that in any process there is an exact equivalence between heat and work. It simply indicates an exact delta U is equal to Q plus W. We got it, a relationship from the first law, isn't it? So we are getting a relationship between the heat and the work of the various forms of energies of the heat involved, of the various forms of energies and the various forms of heat and the work and the relationship between them. We are getting it, isn't it? Fine. We are getting about the enthalpy, del H is equal to del U plus P del V. We are getting about the internal energy. So in this way, we came to know all these things from the first law. Basically, del U is equal to Q plus W, which establishes a relationship between internal energy, heat and the work done. Got it? Various forms of energy also we can say that. However, now listen carefully. It does not tell us about the spontaneity of a process. Means whether the reaction is taking place by itself or not. Means whether it's taking place by itself or what you can say, some external energy is required, some external source is required to carry out this particular process. It does not say anything about it. Means when the reaction is taking place, how the reaction is taking place. Whether it's taking place by itself or some energy is required, some external source is required, some external energy is required. So it does not say anything about the spontaneity of a process, whether the process is spontaneous or not. Alright, whether it is taking place by itself or not, it does not say anything about it. Whether the reaction is feasible or not, feasibility of the process. Whether, suppose we know that heat lost is equal to heat gained. We know that, isn't it? Means suppose if you keep some hot tea outside, after some time you'll see it becomes cold. Alright? That is the heat lost. Now who is gaining the heat? Atmosphere is gaining the heat. Can you show that how the atmosphere is gained and how much heat the atmosphere is gained? What was the initial one and what is the final one? No, you can't. Because atmosphere is a universe here. You cannot show it. So according to the first law, there is some limitations here which you can't show. You can say that what you can say that T is losing the heat, but who is gaining the heat? Heat loss is equal to heat gain, we know that, according to the law of conservation of energy. The total energy remains constant, we know that. But who is gaining the heat? The atmosphere is gaining the heat. But how much? How it is gaining? Can we measure that the atmosphere, how much heat it has gained and what was the previous heat, and now after gaining the heat, whether the same amount of heat it has gained or not? Can we say that? No, it's not possible. Alright, so these are the limitations, we can say that, which we do not know from the first law of thermodynamics, we can say that. Now next. The first law establishes relationship between the heat absorbed and the work performed by a system. Delta U is equal to Q plus W. Already I said it. Clear. However, it places absolutely no restriction on the source of heat or the flow of heat. Alright. For example, suppose let us say this is a metal rod. Alright. I am holding this particular metal rod. Let us say a hot metal rod. Of course, I will not be able to hold it. It's a hot means I will not be able to hold it. A metal rod. Alright. Suppose, let us say I am holding it. Then the heat flows from where? From the hot body to the cold body or from the cold body to the hot body? Does first law say anything about it? Does the first law say anything about it? That the heat is flowing from my hand to the hot body or from the hot body to my hand? You will say, sir, of course, from the metal rod to the cold body. You are able to say this from your previous knowledge. But I am asking you, does the first law tell anything about it, about the flow of the heat? About the direction of the flow of heat? No, it does not. From your previous knowledge, as you have gained, you know that the heat flows from the hot body to the cold body. From there you are saying it. From the metal rod to my body, the heat is going to flow. As a result, from the first itself I said that I will not be able to hold it. Alright, but the first law does not establish any relationship. That what is the direction of the flow of heat? Alright, it does not say anything about it. Fine, that is the second limitation, so we can say that. Now, according to the first law of thermodynamics, the energy of an isolated system is conserved during a specified change, alright, of the state. However, it fails to predict whether the specified change, including a chemical reaction, can occur spontaneously or not. That also I have said you earlier only. It says that for a particular change, heat remains conserved, total energy remains conserved. But whether that particular chemical change, whether that particular reaction is being brought about by itself, spontaneously, alright, whether it is feasible or not, Alright, does it say anything about it? No, nothing about it. In the first point only I have discussed this about with you. So in this way, these are the limitations of the first law of thermodynamics. So basically, first law does not say anything about the spontaneity of the process. The first law does not say anything about the direction of the flow of heat. Alright, direction of the flow of energy. Got it? So in this way, these are the limitations. It does not say anything about the feasibility of the process, that whether the reaction I am writing, it theoretically I am writing, practically whether it will occur or not. You will say that we know it. Of course you know it from your previous knowledge. Again I repeat. But it does not say anything from the first law. From the first law I am asking. From the first law. Are we knowing anything about it? No. So hence, right now we will come to the spontaneity of a process. From the first law itself we will come to the what I can say spontaneity of the process. Then we will move to the second law. Alright, first we will see some definitions related to the second law. Then we will move to the second law. The spontaneous and non-spontaneous process. Now what is spontaneous process? For example, I am holding this pen. Now the pen, I am leaving it. When I leave it, then I cannot, what I can say, stop this pen. It will fall down. It is a spontaneous process. Suppose you are holding some books and the book slips from your hand. Once it starts slipping, you cannot stop it. It will automatically, all the books will fall from your hand. It's a spontaneous process. A stone rolling down the hill, once it starts rolling, got it? You cannot stop it rolling. It will come down by itself. It's a spontaneous process. In the middle you can stop it. That you can do. But it does not require any external agency to be carried out. Further, once it starts rolling, it does not require any external agency to be carried out further. To further roll down, you can say that. But if you want, you can stop in the middle of the process. That you can do it, of course. But that is not my aim now, isn't it? Clear? Similarly, suppose you have taken some ice and you have put it outside. It will melt spontaneously. You do not have to supply heat to it to melt. You can do. But if you don't do also, then also it is going to melt. Alright, so it is a spontaneous process, we can say that. Clear? For example, you have taken some hot tea as I was speaking to you. You take some hot tea and put it outside. After some time, you will see it becomes cool. Isn't it? It becomes cold. So what is that? It is a spontaneous process, we can say that. Water evaporation. It evaporates. Whether water evaporates or the sweat evaporates from our body or the water evaporates from the water bodies. It's a spontaneous process. And evaporation is a spontaneous process. Every time it is taking place. Evaporation. The thing is that sometimes the rate is very high, sometimes the rate is very low. But every time it is taking place. It's a spontaneous process, we can say that. So there are certain process which is spontaneous in nature. Of course, in certain spontaneous process, initially to start the process, some external agency is required. For example, suppose you are burning some paper. You are burning some paper, we can say that. So initially you have to start the reaction. You have to light a matchstick, then you have to burn it. Got it? You have to start the burning. Once it starts burning, after that it will continue to burn. Like suppose you are burning some firecrackers, isn't it? So once you have to just light the crackers, then after that it will burst by itself. It will burn by itself. It will get combustible by itself, we can say that. Clear? So that's a spontaneous process. You will add NaOH to HCl. It forms NaCl in water. It's a spontaneous process, the neutralization reaction. So all these are spontaneous process. I hope you understood what is spontaneous process. Got it? A process which can take place by itself without the assistance of an external agency under the given set of conditions is called a spontaneous process. It does not take the help of an external agency. Might be, again I repeat, might be in the beginning some agency is required to carry out the process. But for when the process is carried out, throughout the entire process, no external help is required. Got it? Throughout. In the beginning you might require. Means you need to start a particular process. But after the process has started, you do not have to provide an external agency. That is a spontaneous process, we can say that. Clear? That is known as a spontaneous process. For example, you are driving a bike. Now, as long as the petrol is there, got it? You are able to drive it. So that is the external agency, the petrol. Isn't it? You start the bike. Of course, you need to start the bike. Then after that, if petrol is there, then the bike is going to run. So the bike is the petrol is the external agency. See, it is not a spontaneous process here. It's a non-spontaneous process. As long as the petrol is there, the bike is going to run. Alright, so that is a non-spontaneous process. For example, here, what you can say, you have taken some acid-related water and you are going for electrolysis. As long as you pass the electric current through it, water is going to dissociate into hydrogen and oxygen. You know that. Electrolysis. Hydrogen will be collected at cathode, oxygen will be collected at anode. Fine. As long as you are passing the electric current, so that is nothing but a non-spontaneous process. As long, I'm using the condition there. When some condition is being enforced, that is called as a non-spontaneous process. We can say that. As long as I am passing. Got it? For example, you have taken some trilate tetroxide, or you have taken some mercuric oxide. As long as you are heating mercuric oxide, you will be getting oxygen from it. You stop heating, you will not get oxygen. Mercuric oxide and heating will give you mercury and oxygen. Upon heating only, it will give you. Isn't it? Itself it will not give, na? Isn't it? Suppose initially you have heated something, so little bit of oxygen you will be getting it. Then if you continue heating, then only you will be getting continuously the supply of oxygen. That's it. We can say that. So it is a non-spontaneous process. So in this way, what you find is that is some process which are non-spontaneous also. We can say that. So a non-spontaneous process is that which has no tendency to occur, in which it is forbidden, the processes, and is made to occur only if energy from outside is continuously supplied. Got it? You have to note this point. If energy from outside is continuously supplied, then only the process will be carried out. Otherwise, the process is forbidden. We cannot carry out the process. For example, electrolysis of water. For example, getting of oxygen from mercuric oxide. You have to heat it continuously, then only you will be getting it. Clear? Then, as I said you, like suppose you need petrol to run a bike. So, you require petrol continuously. It's not that for starting you require the petrol. For starting the bike you require the petrol. After that, no petrol is required. How it is possible? It's not in that way. So, it is a non-spontaneous process. We can say that. Alright. The term spontaneity means also the feasibility of a process, and the spontaneous process are also called as feasible or probable process also. We can say that. Mind it. It will be, listen to it carefully also, understand it also at the same time. That spontaneous process is also called as a feasible process or the probable process. We can say that. So, HCl plus ammonia gives ammonium chloride. It is a spontaneous process. HCl gas plus ammonia gas will give you ammonium chloride upon heating. Alright, clear. Now H2O, liquid, on heating it gives H2O gas. I said you just now, vaporization, we can say that, or evaporation. 2NO plus O, 2NO, nitric oxide is a colorless gas. It reacts with another colorless gas, oxygen, to form a reddish brown colored gas, that is nitrogen dioxide. We can say that. Clear. So in this way, all this process which I was talking to you, got it? These are the examples of the spontaneous reactions. We can say that. Got it? So here you may say that nitric oxide is required. Of course, nitric oxide is required. But once we start, and after that nitric oxide, if you are giving the supply, you can say here also nitric oxide plus oxygen, that also we can say that it is a non-spontaneous. When the supply of nitric oxide comes into being, then only. Otherwise, we can say it's a spontaneous process. We can say that. Clear? In this way, that is, we understood, I think, about the spontaneous and the non-spontaneous process, so to say. What is a spontaneous process and what is a non-spontaneous process? I hope you got it. So, up to this much. Next step we will see it. Thank you.